Now, today we will talk about permutations. Now, the idea here is that we can use permutations because permutations can help us to answer the question in how many ways can we arrange a group of objects? Now, one thing to remember is that there's two ways to arrange a group of objects. One is with order, and the other one is without order. But now we will use permutation when the order matters regarding the way that we want to arrange our objects. So now here, permutations, it can help us to answer the question in how many ways can we arrange a group of objects, but the way that we want to arrange the group of objects is with some kind of an order. So keep that in mind. Now, first, let's start with kind of like an abstract definition. Now, again, when we talk about permutations, I want you to remember that the order matters in permutations. So now, this is the overall definition, but let's just break it down one section at a time. Now here, it says the number of permutations of n items. So n is how many items you have. So keep that in mind. N is how many items we have of a set range of R items. So R, you can think about it as what are the groups that you want to make out of. And groups, I'm going to put it in quotation mark because it's not exactly groups, but I want you to think about it as groups. So N is how many items do you have in total? And R is in what kind of groups do you want to make? Now, this is the overall formula. Again, what this means is that N P of R, let's rewrite that, N parenthesis R, this is equal to n factorial over n minus R factorial. But again, in this case, when we talk about permutations, we most likely will use our calculator here. But know that there is an exact formula for us to find the permutation. Now it says n is how many items do you have, p is to indicate that we're using permutation, and r is what kind of groups that you want to make out of. So this is just notation, npr, with the p it's a little bit bigger than n and r, and that is equal to just this expression. We will just plug in those, but we're not exactly going to be using the equation here. We will concentrate more on the calculator. So let's see. Again, we use permutations when we want to make some kind of arrangement in some group where the order matters. So if we look at some examples here, it says the student body of 10 students wants to elect the president, vice president, and secretary of the treasurer. Now our task in this scenario is that we want to find the number of possibilities. In how many ways can we arrange the given scenario? So let's see. The first thing I want to do is how many individuals are we talking about? Here, it says that the body of students consists of 10. So n is equal to 10. Now R is, okay, what kind of groups are we want to make? So let's see. We want to select the president, a vice president, a secretary, and a treasurer. So it seems that we want to make groups of 4. So that means that R is equal to 4. Now that we have n, and now that we have R, we have a formula. So that means that if we want to find the number of possibilities for this scenario, we will have NPR, and because we know it's P, because the order matters, because once you pick one student to be president, that same student cannot be vice president, neither secretary, or neither treasurer. And that's going to go the same for the other positions. If you choose one person to be vice president, that same person cannot hold another position. So that's why here the order matters, because once you pick one person, then you cannot pick that same person for the other positions. So that's why we decided to use P. All we need to know is N and R, which we already found it. So we want to have N, which is 10, then big P, and then R, which is 4. Now this is going to be equal to N factorial, where N is 10. So we're going to have 10 factorial, parenthesis N minus R, N is 10, R is 4, so we're going to have 10 minus 4 factorial. Now this is the same as 10 factorial over 6 factorial. And this, we can use our calculator, because now we have 6. And remember, factorial, you hit mathematics, and then you go to probability, and then we're going to hit 4. So we have 6 factorial, 10 factorial. So 10 factorial divided by 6 factorial. So 6, where's mathematics? Then we gotta go to probability, and then we're gonna go to option 4. So that means that we can have a total of 5,040 ways we have 5,040 ways for us to rearrange 10 students for them to hold these positions. Now, another way to do it is that we can just plug this in the calculator. 10p4, you can plug this in the calculator. So there's 2 ways to do it. One way is to actually just explicitly put it in the calculator. The other way is to just put the left number, which is 10. Now, we're going to still go to mathematics, and we're going to go to probability. But now notice here in option 2 it says NPR, which is exactly what we want. So we're going to go to option 2, and then we're going to put the right number, which is 4. And notice that we're still going to have the same solution as if we did it explicitly. So there's 2 ways for you to do it. Either you can find out the factorial, put it in the calculator, or you can just put the expression in the calculator. So let's see. Let's look at example 2. So now, let's see. Here it says that the setting that the combination on a 3-digit lock. Now, for this example, I guess pictures will help us. Now, what do they mean by a 3-digit lock? A 3-digit lock is just a lock. So here's our lock. And what's so special about it is that there are 3 digits here. And you need to put like a certain combination in order for entry. Let's say the combination for your lock is 1, 2, 3. And then if you put it right, then it unlocks. So let's say this is a 3-digit lock. Now again, if you want to find permutation, you need to know N. And you also need to know R. So now, let's figure out what N is. How many numbers can you choose from? Well, let's see. On the first slot here, you can choose numbers from 0 to 9. On the second slot here, you can also put any number between 0 and 9. And on the third slot, we can also put zeros between 0 and 9. So that means that in total, we have about 30 numbers to choose from. Because notice that from 0 to 9, that's 10 numbers that you can choose from. 0 to 9, that's 10. So that's 10, I'm sorry. 0 to 9, that's 10. So if you add them all together, in this log, there are 30 numbers that you can choose from. So that means that our overall group, or our N, is just 30. And our R. Now, notice that R is the grouping. But how many numbers do you need in order to try a combination? You need 3 numbers for you to try each of those combinations. So that means that our R is 3, because in a way, If you want to find out the setting for the combination of three-digit number, you need to put three numbers, and if that is correct, then you can open. If not, you need to put another three numbers again and try to see if that can unlock the lock, and so on. So that means that we want to make groups of three. So we got 30 numbers to choose from. We want to make groups of three. We know that the order matters here because when you try to open a lock, you definitely want to put the correct numbers in the correct slot. So that says that it's a permutation now. So now let's see. We want to use NPR where n is 30. We know it's a permutation because we're talking about locks. And we want to make groups of three. So now if we follow our formula that is on top here, that's n factorial divided by n minus r factorial. So n is 30. So we will have 30 factorial divided by 30 minus 3 factorial according to our formula here. Oops, it seems like here is supposed to be a 30, not a 3. So that's 30 factorial. So oops, it's like I don't know how to write 30s. So this is 30 factorial. So now that means that we have 30 factorial divided by 30 minus 3. That's 27, right? So that's 27 factorial. So if we put on our calculator here, we will have 30 factorial divided by 27 factorial, and that is equal to 24. Oops. This is equal to 24,360. So there's 24,360 ways which you can try to unlock this three-digit lock. And again, let's just double check it using the calculator. So that will be 30, mathematics, NPR, that's option 2. And then we're going to put 3 on the right. Yep, we got the same answer. So now, here's your entrance ticket. Just find the number of possibilities for the batting order for 7 players on a 12-person team.